Today we are going to learn how to simplify what's called a complex fraction, and that's a fraction within a fraction. Now we actually already know how to do this. This is just dividing fractions, and we already saw that a couple of days ago. So, looking at fractions with numbers, remember when we divide, here's our division. We can rewrite this as 2/3 divided by 5/4. What's our rule for dividing fractions? Multiplied by the reciprocal. And I won't finish this one because this is a bit basic, but that's the process that we're going to use when we simplify our complex fractions with rational expressions. So don't let all of this scare you, it's just dividing. We already know how to do that. So first, multiply by the reciprocal. So our first fraction is 4 over x plus 2, so we keep that. And then multiply by the reciprocal of the denominator. And then we know how to multiply. Factor if we can. These are already in factored form, so we have nothing to cancel. And then that's our restricted domain, which we'll get to in a minute after we multiply. So our numerator, we have 24. And then our denominator, distributing that out, we get x squared plus 4x plus 4. Now the restricted domain for complex fractions is what's a little bit more challenging. Set all of the denominators equal to 0. This is the denominator of our complex fraction. So we need to set both of those pieces equal to 0. Now in this case, 6 can't equal 0, so we've just got x plus 2 cannot equal 0. And of course, this was our original denominator, or the fraction, the denominator of our first fraction. But that's the same thing. So we get x cannot equal -2. Let's take a look at two more examples. So our first one, again, multiplied by the reciprocal, x plus 2 over x minus 1, that's our first fraction, times the reciprocal of our denominator. They're already in factored form. We have no common factor, so I'm going to go ahead and distribute. In our numerator, we have x squared plus 7x plus 10. Now remember that you are distributing everything when you multiply your numerators and denominators. So in the denominator, we get x squared minus 4x plus 3. For the domain restriction, we need to look at this denominator, and we need to look at this as an entire denominator. So anything that makes the numerator 0 would make the denominator of our original complex fraction 0, or the denominator of our denominator. So we've got x cannot equal 1, 3, or -5. And last example, multiply by the reciprocal. And I'm going to go ahead and factor this because I know that when we multiply by the reciprocal, we cancel any common factors. So you always want that in factored form. And it actually factors or simplifies with its own numerator, as well as the other numerator. Everything in the numerator is canceled, that x stays in the denominator. So we've got 1 over x for the simplified form of our complex fraction. And finally, we'll go back and give our restricted domain. This cannot equal 0, which was factored form over here. This cannot equal 0, and this cannot equal 0. So we've got x cannot equal plus or minus 1, which covers this denominator as well as this one, and x cannot equal 0 from that numerator of the denominator, if that makes sense. And your U-try problem.